Hey everyone, it's Jay, and today we're going to talk about how cells get excited. If you want to understand how your partner gets excited, I'm not going to be a lot of help, but I can talk about cells. A lot of cell behavior is determined by ions crossing the cell membrane. Calcium can cause muscle contraction, neurotransmitter release, or insulin release, depending on the type of cell. An electrochemical gradient pushes an ion either into or out of the cell, but the ion can't diffuse through the lipid bilayer without a doorway. Ion flow down the gradient is regulated by opening and closing ion channels. A potassium channel, for example, will let potassium through the cell membrane but not sodium. When the channel is closed, no ions cross the cell membrane, but when the channel opens, ions will flow down their gradient just like water flows downhill. There are a few different ways ion channels can open, and we're going to discuss 3 today. We're going to discuss ligand-gated ion channels, which open when a chemical binds to the channel. We're going to discuss voltage-gated ion channels, which open when voltage inside the cell changes. And we'll discuss mechanically gated ion channels that open when the cell membrane is distorted. Starting with ligand-gated ion channels, we'll use as an example the nicotinic acetylcholine receptor, which we find at the neuromuscular junction and a lot of other places. This receptor allows sodium to cross the membrane, so positive charge enters the cell, which we call depolarization. The acetylcholine receptor opens when it binds to acetylcholine, its ligand. If there's only a little bit of acetylcholine, only a few receptors open, a little bit of positive charge crosses the membrane, and there will be a small depolarization. If there's a lot of acetylcholine, a lot of receptors open, and there's a larger depolarization. So ligand-gated ion channels like the nicotinic acetylcholine receptor cause a graded membrane depolarization. A graded depolarization just means the change in voltage can be small or large. This will be different from what we see when we talk about voltage-gated sodium channels. Voltage-gated channels open when the voltage inside a cell increases. If we look at a voltage-gated sodium channel, you can see at rest there are some gates blocking the pore, so no sodium ions can cross the membrane. As positive charge enters the cell, the positive charge inside the cell repels the positively charged gates and forces a change in shape that allows sodium to pass through the cell membrane. For now, we're going to ignore the ball that you see floating here. That'll be important down the road. The increase in voltage necessary to open the voltage-gated sodium channel is called the threshold voltage. Below the threshold voltage, the channel is not open. Above the threshold voltage, the gates will open and allow ions to pass. So let's think for a second about what's going to happen if a voltage-gated sodium channel opens. As soon as one voltage-gated sodium channel opens, positive charge flows into the cell, which is going to increase the voltage and open the neighboring channels. The more voltage-gated channels that open, the greater the depolarization in the cell. So as soon as a few voltage-gated sodium channels open, they're going to open all their neighbors in a positive feedback loop. This change in potential is called an action potential instead of a graded potential. It's an action potential because every voltage-gated sodium channel opens. It's an all or none response. There's not bigger and smaller, but every action potential is the same size. Finally, mechanically gated ion channels open when a cell membrane is distorted. I've shown one here where the cell membrane is stretched, opening the channel and allowing ions to pass. Mechanically gated ion channels will also cause a graded depolarization because the greater the distortion, the more channels will open. Okay, to summarize, ions need a channel to cross the cell membrane. Each channel is specific to an ion or group of ions. Ligand-gated ion channels open when they bind a specific ligand or chemical. When they open, it causes a graded depolarization that can be of different sizes. Voltage-gated ion channels open when voltage inside a cell changes. Opening voltage-gated sodium channels causes an action potential, an all or none response. Mechanically gated ion channels open when there's physical distortion of the cell membrane, and that causes a graded membrane potential.